Hi, do you intend to take any competitive exam that tests your quantitative skills? Be it the SAT, ACT, BPA, or MBA entrance, or any banking exam, or the SSC, CGL, that is the Staff Selection Commission combined graduate level test? If so, then you are in the right video. In this video, I'm going to discuss with you a very important topic, that is mixtures and alligation. We shall discuss the concept of mixtures and also the method of alligation. We shall take up certain basic problems and then move on to advanced level problems. So if you want to make the best use of this video, please watch it till the very end, because I'll be giving you tips and tricks, not just the conventional method, but shortcut method to solve complicated problems involving mixtures. This topic is usually tested in most of the competitive exams. So even if you intend to take any other competitive exam other than what I mentioned, this will still be useful for you. But before I proceed, let me introduce myself. My name is Vineet and I am the co-founder of Succeedeazy Tutorials. We specialize in math, English and soft skills. So let's dive in. Mixtures and alligation. Let us first understand what we mean by a mixture. A mixture is a combination of two or more substances mixed in any proportion. Moreover, the substances that form a mixture retain their individual identities. That is, they do not combine chemically to form a new substance. This is the premise on which we solve mixture-related problems in mathematics. So let us understand the types of mixtures. There are basically two types. One, simple mixture that consists of two or more ingredients, and the other, compound mixture, which contains two or more different simple mixtures. Let's now understand what we mean by alligation. Alligation is a process that helps us in solving math problems involving mixtures of ingredients that differ in price or quality or concentration. The method of alligation is based on the concept of weighted average. So if you have done that topic well, you will find this topic of mixtures and alligation pretty easy. Let us now understand the various mixture types. So basically, there are three kinds of mixtures. One, you mix solid with solid. Two, you mix solid with liquid. And three, you mix liquid with liquid. Let's first discuss mixing of solid with solid. So let's take an example of fruits. For example, let's take 2 kilograms of apples, mix it with 1 kilogram of oranges. I understand usually you buy oranges and apples maybe in dozens, but for the sake of simplicity, right now either consider it as kg or you consider it as dozens, doesn't matter. The concept is that total number of parts will remain 2 plus 1, that is 3, either 3 kgs or 3 dozens, doesn't matter. The concentration of apple will be said to be 2 by 3 because 2 parts of it is apple and out of the total 3 parts. Whereas the concentration of orange would be 1 by 3 for the same reason. But the ratio of apple is to orange would be 2:1. However, you know that you can flip the ratio. If you say you want to find the ratio of oranges to apple, obviously that will be 1 by 2. Let's now look at mixture of solid with liquid. So if you mix salt with water, you get a solution of salt and water. Here the solute salt gets dissolved in water. It could be salt or sugar or whatever, similar substance, right? Let's take 200 grams of salt, mix it with 1000 ml or 1 liter of water. Here, the concentration of salt or the concentration of the solution can be calculated by using the formula mass of solute divided by volume of solution. Here the mass is in grams, the volume is in milliliters. So what we get is 200 grams per 1000 ml. This can be simplified to 0.2 grams per ml. Remember, this is the mass per unit volume. Having found the concentration of salt, the percentage concentration can be found by simply multiplying the concentration by 100, that is 0.2 into 100 gives us 20%. Now, let's look at the mixture of liquid with liquid. So if we take 5 liters of milk, mix it with 10 liters of water, we get a 15 liter solution. The concentration of milk will be found by using this formula 5 divided by 5 plus 10, that is 5 by 50, that is 1 by 3 or 33.3%. The concentration of water will be 10 because there is 10 liter of water, but the solution volume is 15 liters, So 10 over 15 would be 2 by 3, that is 66.7%. The ratio of milk is to water will be 5 is to 10 or 1 is to 2, because here we need to take absolute values but keeping the units the same. In a ratio we keep the units the same. So you get 5 by 10 or 1 is to 2. And obviously you can flip it. Water is to milk will be 2 is to 1. Here the formula to find the concentration of liquid in another liquid is always concentration percentage is equal to volume of solute divided by volume of solution. Remember, it is the volume of solution times 100. So concentration would be volume of solute divided by volume of solution. The moment you multiply this by 100, you get a percentage. Let us note a few things here. Solute is the liquid for which the concentration is to be found. Solution is the total mixture of all liquids that are mixed. And what we need to ensure is that we measure the solute as well as the solution in the same unit. Also, another thing is that V by V percent means volume per volume. So now let us take up a problem based on mixture of liquid with liquid. If you mix 20 milliliters of sulfuric acid in 80 milliliters of water, that is a solvent, to create a solution, what is the concentration of the acid, that is solute, in the solution? You may pause the video and come back to it for answers. You can follow this process for all the questions that you see on this video. Did you get 20 by 80, that is 0.25 or 25%? If yes, then I'm sorry, it is not the correct answer. The correct answer would be 20 divided by 20 plus 80, that is 20 but divided by 100, that is 0.2 or 20%. Always remember that when we mix liquid with liquid, the concentration percentage is found by the formula volume of solute divided by volume of the solution times 100. Please remember. Alright, let us now take up some practice problems and look at the solutions to those problems. If a sugar solution contains 17% sugar by weight, what is the percentage of sugar in the solution after 60 minutes if the water evaporates at the rate of 0.5 grams per minute? Please try. Alright, let's look at the solution. So let the solution weight be 100 grams. We know that it contains 17% sugar by weight. So 100 grams of the solution would contain 17 grams of sugar, and the balance 100 minus 17, that is 83 grams, would be water, right? That is the initial condition. What happens then? Water evaporates. And what is the given rate? It evaporates at the rate of 0.5 grams per minute. This is given. In 1 minute, half gram gets evaporated. That is by using unitary method, you can see that if it takes 1 minute for half gram, in 60 minutes, how many grams would you get evaporated? It will be half multiplied by 60, that is 30 grams. So 30 grams will get evaporated, or water will get evaporated in 60 minutes. So what will happen then? Water will evaporate, but sugar will remain. So after evaporation, 100 grams of solution will become how much? 100 minus 30, that is 70 grams, isn't it? So from here itself, we can get the solution. The answer is straight. We will have 17 grams sugar, we will have 70 grams of solution later. So 17 by 70 should be our answer, right? Let's look at it. So 70 gram solution will have 17 grams sugar and balance 83 minus 30, 53 grams of water. This is inconsequential though. Our answer is clear from here. Percentage of sugar in the balanced mixture would be, as I said, 17 over 70 times 100, that is 24.3%. Let's now understand the process of alligation. Let us take an example to see how the process helps us solve mixture related problems. So let us take apples and oranges. Let the apples cost rupees 100 per dozen and the oranges rupees 80 per dozen. Let us take X dozens of apple and Y dozens of oranges. So if X is equal to Y, that means we take apples and oranges in equal measure, then the average cost is going to be 100 plus 80 divided by 2. That is 90 rupees per dozen, right? But if X is greater than Y, that means you take more of higher price product in the mixture. The average is going to be greater than 90. That is, the mean price will be higher, right? And if you take more of lower price item, that is, if Y is greater than X, then the average is going to be less than 90. Here, we should remember that the law of averages works. It says that the cost of the apple orange mixture can never be greater than 100 rupees per dozen, and it can never be lesser than 80 rupees per dozen. Just look at this. If you take all of apples, no oranges, then your maximum cost is going to be 100 rupees per dozen, isn't it? Same way, if you take all of oranges, the minimum cost is going to be 80 rupees per dozen. But if you mix the two, obviously you will get the mixture price somewhere in between. So that is what is the law of averages. So the average cost in a mixture will always be between the lowest and the highest cost. Now let's take up a problem based on mixing of two mixtures. So if 10 liters of dilute hydrochloric acid of 0.3 concentration is mixed with 15 liters of dilute hydrochloric acid of 0.2 concentration, find the concentration of the resulting mixture. Please try. Alright, welcome back. So let's first solve this problem using the conventional way. The conventional way is that, let's say HCl in the first mixture would be how much? The concentration is given as 0.3, the volume of the mixture is given as 10, isn't it? 0.3, 10. For the second one, it is given as 0.2 and 15. We'll use these values. So HCl in the first mixture is 0.3 into 10, that is 3 liters. HCl in the second mixture, for the same logic, would be 0.2 into 15 liters, that is 3 liters. So total quantity of HCl in the mixture is how much? 3 plus 3, that is 6 liters. But it is given that the total quantity of the mixture is 10 plus 15, that is 25 liters, right? So in that 25 liters, how much is HCl? How much is hydrochloric acid? It is 6 liters. So obviously the concentration of HCl in the new mixture is 6 divided by the total volume 25 liters, that is 0.24, or multiply that by 100 to get 24%. Now let's look at another way to solve the same problem using the rule of alligation. Let's arrive at the formula first. Let's say we mix two substances with prices or concentrations P1 and P2, where P2 is greater than P1 and quantities Q1 and Q2. Let the average price or concentration be P. So we know that P will remain between P2 and P1 such that P2 will be greater than P and P will be greater than P1. Now, using the conventional method, we get P equals to P1 times Q1 plus P2 times Q2 divided by the total quantity, that is Q1 plus Q2. Cross multiply that. So P into Q1 plus P into Q2 will be equal to P1 Q1 plus P2 Q2. Take Q1 on one side. So P is here, Q1 is on the right side. Okay, the coefficient is P1, so P1 moves on the left. So it becomes Q1 in bracket P minus P1. Same way, Q2, leave it on the right. Q2 coefficient is P2. So in bracket P2, on the left side you see what is the coefficient of Q2, it is P. So it comes on the right side, plus P becomes minus P. So that is how you get P2 minus P. Now to get ratio Q1 upon Q2, just take Q2, bring it down on the left side. So Q1 upon Q2, P2 minus P remains as it is, P minus P1 goes down on the right side. So what you get is Q1 upon Q2 is equal to P2 minus P upon P minus P1. That this is the rule of alligation when two substances are mixed. This formula is going to be immensely useful to you. So please note this. Remember that we took P2 as greater than P and P greater than P1. This was to ensure that we deal with positive numbers. But suppose you inadvertently get negative numbers, then what you can do is just Q1 upon Q2, you just multiply both numerator and denominator by minus 1. So you will get P minus P2 upon P1 minus P, right? So here P will be greater than P2 and P1 will be greater than P. If you fall into that trap, then you can use this formula. But my suggestion to you will be always work on this. Just take P2 as the higher concentration or the higher price and P1 as the lower price. So that will avoid negative numbers. Okay. Now let us apply the rule of alligation. Let's do this problem. Please try and then come back. Okay, let's now look at the solution. Let's read the question first. If 10 liters of dilute hydrochloric acid of 0.3 concentration is mixed with 15 liters of dilute hydrochloric acid of 0.2 concentration, find the concentration of the resulting mixture. So we see quantity, we see concentration, we see another quantity, we see the concentration, and we are mixing two liquids to get another liquid. We want to find the concentration of the resulting mixture. Alright. So let's take P2 greater than P, P greater than P1. We know 0.3 is greater than 0.2. So let's take P2 as 0.3 and P1 as 0.2. Let's use the data. So mixture 1 has The concentration P1 is 0.2 and the quantity is 15 liters. Let's recheck. 0.2 concentration, 15 liters, right? And 0.3 is 10 liters. So 0.2 is 15 liters, 0.3 is 10 liters, absolutely. Then what you do, the trick is, you keep P1 on one side and P2 on the other side, okay? So P1 is 0.2. On the left side, generally I put P1, but it is not essential. But going forward, taking P1 on the left side, so 0.2 is, I put the concentration here, on the right side P2 as 0.3. Then after that, in the next line, in the next row, I put P as the average concentration. Now, just take the differences. Here, the difference between 0.3 and P would be 0.3 minus P. 0.3 is greater than P, and hence I put 0.3 minus P. Here, P is greater than 0.2, so the difference between 0.2 and P would be P minus 0.2, keeping positive numbers on both sides. The method of alligation clearly says that Q1 upon Q2, whatever is this ratio, you have taken P1 first and P2 second, so this will be Q1, this will be Q2, so Q1 upon Q2 ratio would be 0.3 minus P divided by P minus 0.2. Here, this is a visual method. If you don't want to use this method, then you can straight away use the formula. It is absolutely the same thing. I hope you can relate to that. So what we get is Q1 upon Q2 is 0.3 minus P divided by P minus 0.2. Now we get Q1 upon Q2 equals to 0.3 minus P divided by P minus 0.2. What we need to find is P. But we already know Q1 and Q2. So let's substitute the values. So Q1 is 15, Q2 is 10. So 15 upon 10 equals to 0.3 minus P divided by P minus 0.2. Cross multiply. What you get is 15 times P minus 15 into 0.2 would be 3 equals 10 into 0.3 would be 3 minus 10P. Take P on one side, so it goes on the left side. So minus 10 goes on the left side, it becomes 25P. Minus 3 goes on the right side, it becomes 3 plus 3, that is 6. So P will be equal to 6 divided by 25, that is 0.24. Multiply that by 100 to get 24%. That's your answer. Let's look at another question. In what ratio should you mix a 10% concentration sugar solution with a 60% concentration sugar solution so as to get a solution of 30% concentration? Again, look at the question. Concentration 1, concentration 2, and you get P. So here no quantities are not given explicitly. Remember, you are given only the concentrations and the ratio is asked. So if the absolute quantities are not given, the ratios can still be found. How? Okay, let's look at the solution. If you want to try, you can pause and come back. Okay, so P1 is given as 10%, P2 is given as 60%. Deliberately, I have taken P2 as the higher value for the reasons that I shared to you before. So P2 is 60%, P1 is 10%. The average concentration is given as 30%. The quantities Q1 and Q2 need to be found. The ratio, not the absolute quantities, only the ratio is to be found. So we can still do that. How? We will use that formula now straight away. Q1 upon Q2 is P2 minus P divided by P minus P1. Even if you look at the visualization, you still get the same thing. P2 is greater than P, so here you will get P2 minus P. And here, since P will be greater than P1, so here the difference would be P minus P. And later you can substitute 30% for P, right? So what you get here is, because this is Q1, so Q1 upon Q2 will be this ratio, that is P2 minus P divided by P minus P1. So whether you look at the visualization or you remember the formula of alligation, it doesn't matter, it is the same thing. So Q1 upon Q2 will be equal to P2 is 60, 60 minus P is 30 divided by P is 30 minus P1 is 10. So 30 minus 10. What you get is 30 by 20, that is 3 by 2. That's the ratio of combining the two quantities Q1 versus Q2 is 3:2. That's our final answer. Next question. In a school lab, a student is provided sodium chloride, that is NaCl solution of 4.5% strength and 100 milliliters of water. In what ratio should the student mix the two so as to get sodium chloride solution of 0.9% strength? Please try this. It's a good question. Let's now look at the solution. Taking P2 greater than P greater than P1, the greater concentration is 4.5%. So I'm taking P2 equals to 4.5%, and P1 the concentration is not given, but it is important to note that since the concentration is not given and it is pure water, so the concentration of water will be taken as 0%. This is an important step. And the concentration, the average concentration or the mean concentration, P, is given as 0.9%. Please look at the question. Mixing for solution of 4.5% strength with 100 milliliters of water. So the strength is here in this sodium chloride solution, but the strength of the concentration of water is, there is no sodium chloride in that, it is 0%. So this is an important step. Now what we need to find, in what ratio should the solutions be mixed so as to get a mean concentration of 0.9%, right? Water on one side, NaCl on the other side. Water I took as P1 because this was lower, 0%. Okay, so P1 and then P2, 0%, 4.5%. Mean P% comes in between. The difference of P2 and P1, difference of P2 and P is 4.5 minus P, and the difference of P1 and P is P minus 0, that is P. So Q1 upon Q2 will be equal to 4.5 minus P divided by P. P minus 0 is P. Now we know the value of P, that is 0.9%. Just substitute that. So what we get is Q1 upon Q2 is 4.5 minus 0.9 divided by 0.9. That is 3.6 divided by 0.9. That is 4 over 1. So Q1 upon Q2 is 4 over 1. That is Q1 we took as water. You remember? Here P1 is 0%. This was water. So Q1 is water. So we got Q1 is 4 parts. Q2 is 1 part. So that is water over NaCl is 4 over 1. That's the ratio. But water is given as 100 ml. Look at the question. You mix with 100 ml of water. So water is given as 100 ml. That means let's take 4x equals to 100 just to understand what is that 1 part. So 4 parts are 4 parts water, meaning 4x equals to 100. So x will be equal to 100 over 4. That is 25 ml. So 1 part of water is 25 ml. If 4 parts is water, 1 part is NaCl. That means NaCl is going to be how much? 25 milliliters. We already know this one part, right? So water over NaCl will be equal to 100 ml over 25 ml. Look, 100 ml is 4 parts, it is coming from here. And 25 ml is 1 part, it is coming from here. Okay? Here we just found what that 1 part is equal to. So we can safely say that the ratio of water is to NaCl would be 100 ml is to 25 ml. So the question basically asked us, in what ratio should the student mix the two so as to get an NaCl solution of 0.9% strength? The answer to that question was very clear. We should mix it in 4:1 strength. But if the question asked us how much NaCl solution will need to be added to 100 ml of water, then the answer would be 25 ml. So both are the variations of the same question. So that brings us to the end of this video. I hope you like the content. If yes, please do like, subscribe and share. It means a lot to us. In the next video, I intend to take up compound mixtures involving up to 3 mixtures. So please watch that video if you want to go to the next level. See you in the next video very soon.